All right, so we've got a circuit here with a 12-volt battery, a 2 ohm resistor, and a 3 ohm resistor. We want to find the equivalent resistance. We would find the current throughout the entire circuit, and then we want to make a determination after that which is the same. Is it the voltage that's the same through the 2 resistors, or is it the current that's the same through the 2 resistors? Well, these are in series with each other. So, since they are in series, we're going to simply add them up to find the equivalent resistance. So the equivalent resistance is 5 ohms. Then the current total, well, we're going to say that V over R is equal to I. So that's going to be the 12 volts over the 5 ohms of resistance, which gives us 2.4, sorry about the writing, 2.4 amps across the battery. 2.4 amps total across the battery and the circuit as a whole. Now we need to determine, is it the voltage that's the same for each resistor, or is it the current that is the same? Well, any current that goes through the battery is going to go through this and also must go through the other resistor as well. If it was water flowing through a pump and then down a couple of waterfalls, it would have to go through both waterfalls. The current is the same when in series. So that means that this is 2.4 amps, as is also this. They are both 2.4 amps of current. And so now we simply apply Ohm's law to each resistor individually. So V equals IR. But the voltage for resistor 1 is equal to the current across resistor 1 times the resistance of resistor 1. And the same thing for resistor 2. So let's see, the current across resistor 1 is again 2.4 amps. I'm going to multiply that by the resistance, which is 2 ohms for resistor 1. And that gives us 4.8. And that is volts. Here we've got 2.4 amps times the 3 ohms of resistance, and that gives us 7.2 volts. All right, so let's move on to a parallel circuit. Now we've got 12 volts here. Let's make R1 equal to 2 ohms yet again, and then we're going to also make R2 equal to 3 ohms. So what are all those things? Again, what is the equivalent resistance? What is the current across the entire circuit? The voltages for each of the 2 resistors and the currents for each of the 2. So let's do that. All right, so in this case, we're going to find the equivalent resistance by taking 1 over the equivalent resistance equals 1 over R1 plus 1 over R2. R1 is 2 and R2 is 3, so we plug in those values and we find the common denominator, and we find that 1 over the equivalent resistance is equal to 5/6. Notice that I'm making a big deal of the fact that it's over 1 over the equivalent resistance, because the most common mistake by far and away is to say that the equivalent resistance is equal to 5/6. It is not. 5/6 is equal to 1 over the equivalent resistance. So you must now take the reciprocal. So the equivalent resistance is equal to 6/5, which is equal to 1.2 ohms. That is the equivalent resistance. Not 5/6, but 6/5. You must take the reciprocal. So let's go back up. This is equal to 1.2. Now everything else goes similar to the other situation. So we have V over R is equal to I. So that's going to be the 12 volts over 1.2 ohms. That gives me 10 amps. Now you must recognize what is going to be the same for each resistor. Is it the current? No, the current's being split. It can go this way or it could go that way. Instead, it is the voltage that is the same. So this is going to be 12 volts in each case. And so now you apply Ohm's law to each resistor. So this is for resistor 1, this is resistor 2. Plug in those values, 12 volts over 2 ohms. And then this will be the 12 volts over the 3 ohms, and that'll give you the current through each. All right, if you look at this one here, how can we do this? If it's 12 volts, say it's 2, 3, and 4 ohms respectively, break it into parts. Recognize that these two are in series with each other. Solve that first. That would give you 5 ohms of equivalent resistance, and then you put that in parallel with this. So you would have to do with you would be like having a 5 ohm resistor in parallel with a 4 ohm resistor.